All right. Thanks for being here. Happy first class day for us after spring break. I know the transition is always a little bit rocky, but we're going to do our best. In general, the class is now starting to transition to the fun stuff, from my perspective, or the difficult stuff from your perspective. So if you're at the point now where you feel like you're not understanding stuff, if you're feeling a little lost, come talk with me or go to the STEM Center, go to the tutors. They're here for you to help you do well in this class. So if you're feeling behind, now's the time for you to come talk about it. Okay, we did that. So let's get started. We've got the new unit. Let's go down here. So we're still in unit 4, but remember we've broken this down into subunits. First one is classes. We've gone through that. I've updated this PowerPoint. So if you have the old version, go ahead and download the new version. That it's got all the new slides in there. So I'm just updating the same PowerPoint file, and that's where all the slides live. So now we're in this new subunit. I've got the packet here. That's the packet assignment. And then we'll have homework 4 and lab 5, which if you click on them currently, there's nothing there yet. That's because I have to go write it up, and I'll do that tomorrow. So they'll be officially assigned on Thursday. Or if you're an early bird and you check tomorrow and it's there, yeah. Okay. All right, so we're going to start at slide 58. Again, this is just one very long slide deck. So we're starting at slide 58. And just to remind you, we're talking about object-oriented programming in this whole unit. And so we're breaking it down into different things. So first we talked about what are the principles of object-oriented. These are sort of our guiding principles as we go and explore what does this mean for us in Java. So we talked about classes of what are they? What are the different components? This is stuff that was covered on the exam. What can we do with them? And so now we're going to look at inheritance, where we're going to build this sort of family tree of classes. And then the next subunit is these last two bullet points. Okay, so we're in subunit 2, inheritance. The assignments are going to be lab 5 and homework 4. Lab 5 is we're gonna work on it in class as per usual. This one is really, really important. This is like I find that lab 5 is always the watershed moment where stuff starts making sense, or it's like the biggest mental leap for us to overcome. It's really cool to watch as an instructor, and I hope it's also cool for you as a student. So that's why it's got asterisks there. And then we'll have homework 4, which I'm thinking is inheritance practice, where I'll make you create a bank. So I'll give you more information on that on Thursday, definitely. Okay, let's talk about inheritance. So chances are when you hear the word inheritance, maybe one of two things or more come up in your head. One of which is like if you've got genes where certain properties are inherited, depending on if someone is unaffected or affected by something, and then someone may inherit that, yeah, whatever it is. So that's one version. Another is maybe like if you have like a rich relative die and then you get your inheritance of.
I'm not sure that, I somehow doubt that Scrooge would ever want to let anyone inherit as well.
Maybe. But this isn't quite the kind of inheritance we're talking about. Some similar things apply. But let's talk about what it specifically means for us. So our kind of inheritance is all about reusing code, where we write some code and we want to be able to reuse these things in later code that we write. So this is an example where we're going to see something like this, maybe a simpler version, where let's say we've got a person class, and that person has a name and designation. I don't know what designation means. But we'll look at where a person has like a name, an age, and an address, place they live at, right? And so the methods could be person learns, person walks, person eats, things a person can do, right? And let's say later on we want to create more specific classes where we want to have a programmer class or a dancer class or a student class where the programmer is a person. So a programmer should have like a name and maybe where they work. They should also have an age. A dancer should have all the things that a person has, but also the things that are specific to a dancer. So this is the idea where we want to be able to reuse code that we've already written and do something new. It makes it easier to maintain and update things. Okay, so the main idea we're going to talk about here is this idea of is A and is not A. So let me set up my tablet here. Whoa, it disconnected. I'm back. I think I gotta get a new dongle thing. And now it's weird. Let's try that again. Better. Great. Okay, so we have this kind of intuitive notion of something is something else, right? So like a programmer is a person, unless the programmer is ChatGPT, but we're assuming that a programmer is a person. A dancer is a person. And so let's draw this kind of family tree with shapes. So, do I have space? No, I don't. Okay.
How about I start?
Okay, go for it.
So you want to,
Well, let me do this example, and then I have examples in the packet for you to draw. So let me show you what I'm kind of looking for first. So looking at like circle and shape is more general, right? A circle is a shape. A shape is not necessarily a circle. Yeah, because it's too broad. So we would write shape up on top and then a circle down below. So like, and as we go up, we see this is a relationship. Okay, so triangle, is a triangle a circle? No. Is a triangle a shape? Yeah. A square isn't a circle or a triangle. But maybe, so rhombus, that's kind of like the slanty square. And a quadrilateral is just anything with four sides. So maybe we should say a quadrilateral and a square is a quadrilateral. So is a rhombus. Then so too octagon. Right? So we can see that a rhombus is a quadrilateral. A rhombus is also a shape. And since there's no way to get from circle to triangle, a circle is not a triangle. And so we can see that with this sort of diagram. Okay, so this is your first packet problem. So take a minute. I've got examples for car, vehicle, Tesla, tractor. Oh yeah, sure there. Person, student, employee. So, start off easy. Figure out what's more general and what's more specific. And then we've got all of our water extravaganza. So feel free as you go, if you want to think of more examples, do that too. Yeah, and also like talk with your neighbors. See, did they draw it the same way that you did? we'll come back. So take maybe 1 minute to try and dry it yourself and then turn to your neighbor. Let's All right, I'm gonna do the loop. Yeah, this may be it depends situation, yeah. Like, is Coca-Cola water?
It contains water.
It contains water, is that what we're talking about?
Wouldn't that technically mean that all drinks have all drinks technically count as water since most of them contain?
So, I'm drinking tea right now, is tea water?
Yes.
Yes.
Is coffee water?
Hmm.
I feel this is a decision that you personally need to make.
Well, not all drinks are water because you could drink maple syrup. No, that contains water.
Does maple syrup also contain water? I mean.
No, the water boiled out, the water boiled out.
I love when we get to talk about the addictive stuff.
But this is where it's
Two, good question.
not all every drinks is soft drink. I don't put the definition for soft drinks because I was confused and it basically says non-alcoholic. But especially if it's sparkling or not carbonated.
Yeah, so is, so. This is an important example that we will discuss later. That's something that you might make that. others don't. Like most of us. Okay, so what are they talking about? Water? Yeah. Yeah. So like, is San Pellegrino? So it's sparkling for sure. You get sparkling? Did I miss sparkling? Thought I did. No, I didn't put it in there. Oops. If we were to add sparkling, I mean, not that you have to write it down, like if we were to add it, what would that look like? how that refactor your hierarchy here. Yeah. Water base versus water drink, okay. That's a choice. Well, that I think makes a lot of sense. Okay. Water is a soft drink, okay. Okay, yeah. I mean, that is like, so you're making decisions on what is that is a relationship. And so if it's not possible for a sprite to.
Wait a second, what's the deduction? What's on my list? Due to the trade class?
This is the company. The drinks is.
Wait, what's the?
These are technically, Coca-Cola is technically on Sprite.
Yeah, okay.
So it's both company and drink.
Yeah, but does
Sprite
Sprite come from, like, is it like a type of Coca-Cola? Oh, yes.
Go against what you can.
Okay, so we found that there are decisions to be made here, right? Absolutely, there are decisions to be made. So either, and I think it probably makes more sense. Some people in the back had it at like 2 trees where we've got, what is it? Soft drink and then water, where we have like, this is where your Sprite, where your Coca-Cola, Dr. Pepper, and then your water is like San Pellegrino, bubbly, and was it LaCroix? So I think this maybe would make sense to me, especially if we rely on this is a relationship where Sprite is a soft drink, but Sprite is not Coca-Cola or Dr. Pepper. Like they're completely different drinks.
I looked at the definition of soft drink and it's for any drink that is carbonated, not necessarily sweetened, but carbonated.
So,
Technically, you can
Is-
put non-sweetened.
so did that mean,
Carbonated
Yeah.
under soft drink.
Everything that you're-
And instead, what I did was that I put a sugary drink, a subset of soft drink, and then put all of the rest of the subsets.
okay. So you've got sugary up here, but then since like all of these are also carbonated, like San Pellegrino, bubbly, and LaCroix, those are also soft drinks?
Yeah.
Okay, that's a choice. Any other insights?
What was the difference between sugary drinks and not sugary drinks? So like, would LaCroix be considered a sugary drink?
Oh, yeah, um, yeah, so maybe sugary, yeah, I think you're right, where it doesn't fit with this configuration that I've drawn. Because if we had this edge here, where sugary is on top, then that says San Pellegrino is water and is a soft drink and is sugary, which is not true. So yeah, so maybe we would need sugary like at this level.
I mean, all of them are soft drinks though, except for water.
Yeah.
Oh, those meant to say sparkling water? Okay, they're all soft drinks.
Well, this just says water.
Oh, you said it was like,
You would mind?
no, you said like, you need sparkling in there, like, you have to put the word sparkling.
It's water. now.
Well, I think so. Water is its own thing. Sparkling is a property that is separate from water. Like you can have flat water, or what is it called? Still water? And then
It's water.
sparkling water. Yeah, so still water, since we're in the US, I think we assume that water is just still water. Yeah, so like depending on the assumptions you make, this can look different. But this is going to be really helpful because we have important questions of like, let's say we have a sparkling thing, like a sparkling aspect, and technically all of these are sparkling. And so we say that Dr. Pepper is sparkling. LaCroix is sparkling, but LaCroix is also water. So we've got two is a relationships happening here. We'll talk about this. Okay, so we're gonna go so we've talked about this hierarchy thing. Let's transition into actual code. So we're gonna go with that second example of person, student, employee. So chances are it looked like this. Did anybody get something substantially different? Great. So this is our hierarchy. This is what we want to do. So let's say our person has the field would be name, age, and
Do we open Eclipse yet?
yes, please do. I haven't opened it on mine yet. Let me do that and let it load. So we're going to start with the person class, and then we're going to figure out how do we make students. Okay. So let's close these. Okay. Let's make a new class. And my package, I'm going to make a new package because we're in a new subunit. We had U 4.1, so now I'm going to say we're in U 4.2. And the class name is person because we're creating a person. This is the unit where we figure out what all these other options are. So this is why I think it's fun because we're starting to really get into it and see the different customization options we can do. Okay, no main, just finish. And this is going to be super basic for the purposes of example.
My Eclipse is taking forever to load.
Oh, I hate that. Okay, so it's going to be simple. So we're going to have field for person being, what type is name? String. Coming back from spring break is not only hard for students, it's also hard for instructors. Age and address, right? Super basic. Let's do the whole thing. Let's just get getters and setters. And let's make a constructor. Maybe we'll just keep it simple and say, if you give me a name, I will say you're a baby and you live at 123.
What was that?
No main method. Leave it empty. So let's just assume that we're going to get a name and then we have created a baby. Okay, super simple class. We've got our constructor here. We've got our getters and setters, our methods, and we've got our fields over here. All right. We've got our person class. I want to additionally make a student class. So me not knowing about anything inheritance or what we're about to talk about, I want my student to also, maybe I want my student to have a GPA, but I also want them to have name, age, and address, right? Because a student is a person. So naive me says, let's make a new class. I'm going to name it bad student because we're going to make an actual good student later. So bad student, this is what not to do. So I've got all this stuff in person that I want to carry over to student. So here's an idea. Select all that, copy, paste. And then I can add an additional field. GPA is a double. Maybe we have to rename the constructor because we're not constructing a person anymore. We're constructing a student. Or no, the name of the class is bad student. And then
But
the name parameter, bless you. What about it? Oh, wait, you're right. Thank you. This dot name equals name. You're right. Thank you. I forgot about that. Let's add that back here. Okay. Maybe our student has a study method, and by studying, then they add 0.1 to their GPA. This dot GPA plus equals 0.1. It's silly, but maybe. Right, so we use the GPA, and our baby who lives at 123 Main Street can study and raise their GPA.
is this bad student or student?
This is bad student. Okay, so we've got bad student. What's the problem here? I mean, I know I had the answer in the slides earlier, but like, we've got person and we've got student. And they both do what we want them to. They both have these methods and have the same fields. What's the problem here? So the issue here is that we've copied and pasted it. One potential issue is that what if the old version, so maybe we made some colossal, like we did make a colossal mistake in person where I forgot to say this dot name equals name, right? And I just copied that old code, pasted it over to student, but then, oh no, I completely forgot to do something. Then I have to change it in student and I have to change it in person. If it's just like one little line of code, maybe not a big deal. But if it's a lot more than that, then that's a problem. So I could copy garbage. And there's this idea of garbage in, garbage out, where if the original class that I'm working with has some really significant flaws, then the new class that I just copied and pasted also has those significant flaws.
Inheriting a defect.
Is code inheriting?
No, and it's called.
Inheriting a defect. Yeah, exactly. Yeah, and so maybe if I decide to change the format that I want the address in, or maybe if I want to specify that the name has to be like last comma first instead of first last, then if I make it in person, I have to go and make that same change in student. And the other thing, which is the big thing that we want to address with inheritance, is over here we said that a student is a person. But in the code that we have, I don't know, there's no reference to person anywhere. These two code files aren't related at all. So like if we did a control F and we did search for person, doesn't show up. They're not related. Okay. The way that we link those together is with a word called extends. And that's how we actually represent that person-student relationship, where we can say that a student is a person. And the way that it looks, the way we actually make that relationship in code is is our class signature. So you know all the way up at the top where we say public class bad student or public class person. That's what we call the class signature. And so we make a change to the class signature for student. Okay, so we want to say public class student extends person. We could type that manually, but I'm going to create a new class and show you how to do that. So new class. So here's where I'm going to make the class name student. And there's an option for superclass here. This is what we're looking at. So up until now, every superclass has been java.lang.object. We're going to make it something different. So if I click browse over here to the right, and I'm going to start typing capital P-E-R-S-O-N, then it eventually comes up of person from package U4.2 from the project CS222 in class in the source folder. That's mine. That's the one that I wrote. So I want to choose that one. So double click on it or click OK. And we're good to go. So now the superclass is U4.2 dot person. Questions? For VS Code, give me a second. Let me see. Do I have a sample Java project? Yes, I do. Okay, so I'm going to make a new class. Oh, it's not looking.
Superclass, that's the superclass.
I did not delete bad student, nor did I delete person.
Hey. This one's not even used to any person.
Let's talk about it afterwards. Okay, so if you do Control-Shift-P and then new Java file, and then we've got options, class. Let's see. Here for VS Code, I think the easiest is to just say like actually type extends person yourself. This is something that you can do in Eclipse too if you forget. Yeah, so like if you forget to type that person is a superclass, you can say extends person and then you're good to go. It'll probably ask to import it. But it should work that way. Does that help? Do you have the person class? Let me come look at it. So. All right. So now we're at this point where we've said here's the superclass. There's something here we can talk about, but let's not check anything and just continue on. Finish. Great, we have public class student extends person, but we've got an error. The arrow says implicit superconstructor person is undefined for default constructor. Must define an explicit constructor. We're going to talk about this. Okay, let's see. Do we have anything interesting to say about this? Yes, I do. So now that student extends person, we don't need to type all that code anymore. We don't need to say private string name, private int age. We don't need to say that because the things get inherited. The fields and methods that were in person get inherited into student. So let's see, what sort of new fields do we want to add? We decided GPA, so private double GPA. And then public void study, which adds GPA plus equals 0.1. Right? So these are the new things that we've got in student. Let's just make a silly method to test. Can we say, maybe we want to print this dot. Oh, look, if I start to type methods, get address, get age, get name, those all come up. Those are from person. So all of those methods are still there, even though we don't type them in this file. So those things get inherited. So like we can get the person's age. And so on. So that data is still there. We can add new fields. So we can add GPA. We can add new methods like get GPA or study. That's something new that person didn't have. We can also do what's called overwriting existing methods. Let me know when I can go back to person. All right, I'm going back to person. So let's make a quick toString method. And I'll say return person plus their name. Very simple. All right, I'm going to make a quick driver class just to test this out, where I'm creating a person and then printing them. So class, I'll call it people demo, and I'll give it a main. Finish.
Did the ones just modified for the getters and setters in person be public or private?
The setters and getters, I think in general should be public. I mean, it obviously depends. Let's make a person Bob, named Bob. And then let's print Bob. So what should happen is it should say person Bob, because that's what we defined in toString. It's got an error, that's okay. So it says person Bob. Great. It did what we said it would do. In students, let's make a student now. So, or actually, Okay, so we've got this error. Let's talk about it. So when we're looking at inherited classes, we need to define our own constructor. So we've got a constructor for person, but now we've got some fields here that person doesn't know what to do with. And so because of that, student needs its own constructor. So we'll set GPA equal to 0. And this is the information that we've got. So maybe we try to do this dot name equals name. Does that work? The field person dot name is not visible. Which makes sense, right? The name field was private in person. So it makes sense that we're not able to access name directly. But there's got to be a better way than saying like this dot set name. There's got to be a better way to do it than that. The answer is that there is. So what we do is we make a call to super, and we kind of have to like talk about things, and then like it's a lot of going back and forth for this one. Where we call what's called the super constructor. Super constructor is the constructor for person. And so this kicks it up the chain and says, hey, person, create a person and assign these fields. So I've given you a name. Also make yourself a baby and say you live at 123 Main Street. Okay, so if we do that and save, our errors go away. And then we can try the demo. So now if we do this, we get person Bob and person Bob, which makes sense. So with inheritance, fields and methods from the original class are inherited. And they'll stay that way, so they won't change unless you say they should change. So in this case, we're taking this toString method and we're not changing it in student. So when we ask to print student Bob, it gives us the same thing. If we want something different, we have to specify that. So let's put it here. And then maybe we'll do the same thing, but just say the name, except we can't access name because it's private. How do we get around that? Super? No.
Okay.
Yeah, we get it. We've got a getter for name. That's public. We can use that. So that's one of the suggestions here. Or we could just type it. So now we've got student get name. And this should give us student Bob. Ready to try it? Okay, going to the demo. Hooray. Now we've got person Bob and student Bob.
Oh,
Back to student. Anybody need more time? Okay, I'm about to go back to the slides. Okay, so student can add new fields, can add new methods, can override existing methods like toString. We've overridden it to say, you don't do that now, now you do this. We cannot remove fields, we cannot remove methods. So the name, age, address, we can't just decide, no, I don't want a student to have an address. It's always going to have that. We cannot remove methods. So we can't say, oh, do away with get age. We don't need that anymore. And the new class has to specify its own constructors. So that's where our first error came from. All right, so problem 2. On the packet, there's not room to write there so much, but I would like you to maybe talk with your neighbor, make an employee class. We've got person, student, employee, this hierarchy. So we've got students. So maybe keep it really simple. What do we want to add for an employee? Is it like salary or company or something like that? And maybe get a raise or something. Keep it simple. Create a class called employee that extends the person class and add maybe 1 or 2 new fields and add 1 or 2 new methods and then override toString. Sound good? Okay, take a few moments and do that. And then once you're done, we just put a check mark there. Oh, yeah. I also have, we didn't do.
Yeah, anyway, I think go back to-
The code?
I didn't get it.
Is this what you want?
Go to.
I am a student.
Go down.
This doesn't really matter. That was just for illustration purposes. You can add it any one. This was to show that you can use the get age method, even though we don't define it in here. Add student. So this is the way not to do it, because like you shouldn't have this information in student. All right, I'm gonna do a lap.
You can go back.
People demo. Cool. So in people demo, now. Yeah, yeah, I honestly think it's weird. Like actually like that. Cause that's what, like each class needs to be simplified. So that is in, can follow along, but in terms of testing, it's not gonna be easier.
What do you see there? I'd like, what is this, like, just, all of it, that's one thing.
So this is, when we talk about inheritance, technically, we tend to create a lot of learning classes. And they'll ask for like these files,
Oh, okay, I was just dealing with this.
yeah, separate files,
Okay.
separate files. It's about a salary and a company. What requires me? Great. Oh, wait, you want me to switch? Which one?
Student.
Student. Yeah, no, go away, Zoom. All right, so I think a lot of you have gotten there. Right, so once we've got the idea of here's a student and it extends a person. So let's make an employee class. So employee, I want to make it super class a person. Does that work? person. Let's try I'm gonna try clicking the constructors from superclass just to see what happens. Oh, look, it makes that very basic constructor with the call to super for me. So either I check that box and it does this, or I type the whatever, 1, 2, 3, 4, 5, 6 words myself. So those are our options. So you probably have more, but let's say private double salary. So in the constructor, let's see, salary, let's make them, wait, hundreds, thousands. Is that billion? I think that's a billion. We're making them a billionaire. And maybe this person is Jeff Bezos. So, but we've created an employee that has a salary and has a company. One thing I saw someone do, like grind, which is where they work super hard and then,
More like crunch.
okay, yeah, maybe let's do crunch. Okay. So let's say maybe the salary, increases by 10%. 1.1. Oh, wait, yeah, no, you're right. Math is hard. Thank you. And then let's add, so you don't need to copy this down if you've already got your employee. And toString, we say employee with a name. And so this is pretty much all we need to do for a very simple employee. So I'm gonna go and test it out. Where we say, employee, let's name them Jeff, because that's apparently what we've created. And then we could print Jeff. If we wanted Jeff to work a whole bunch, say .crunch, and that increases his salary. So that's kind of how we use those objects and what we need to do in order to distinguish when we print them. Okay. Ready to go back to the slides?
Wait. What is the toString in student?
Where's the toString for the student? I put it right after the constructor. You could put it wherever you want. Do you have a question?
Oh, you just go back to the employee, so I just want to be.
I mean, you don't have to do this for Crunch. If you've got another method for your employee, then do that in person demo or people demo, whatever it's called. Do you have a question? No? Okay. Yeah. Yeah, that's a good idea. Employee Jeff. Wait, let's say Let's print the salary just for fun. Aha. Jeff makes so much money. That's just modifying the toString. That's something that we do. All right. Any questions?
Back to, yeah, the, for Java.
So we've got our fields, got our constructor, then we've got our methods. Other questions? All right. I'll give you a second. All right, I'm about to go back to the slides. Okay. So we've talked about this. Here's what employee has new fields, new methods, can't remove anything, has to have its own constructor. Okay, so let's talk about how it works. And because after this, we've got some true false problems. Oh, wait, no, we have problem 3. All right, so let's talk about this. So if we have a private thing in person, so like name, it's not directly accessible. We can't type this dot name. But private doesn't mean it's not present, right? The person still has a name. We can still call the getName method. So it's still there. We just can't directly access it. We saw before we defined toString that if you have a method in person and you didn't define it in student or didn't define it in employee, it gets inherited unchanged. If we have a constructor in person, does that mean that we don't need a constructor in student? No, we have to have a constructor in student. Oh yeah, I rewatched the John Mulaney stand-up, the Radio City one, and so I put all these in here. Okay, if we've got a method in person and we want to redefine it in student, yeah, perfectly fine. If we want to, let's say we have, I don't know, address. Let's say address, like get address in person is public. Could we make it private in student? So the student like can't tell anyone their address? No. We can't lessen the visibility of anything that's inherited. We can only make it more visible, I think. Or like, if it's, the question is lessen visibility. So get address, we cannot reduce that visibility. Can we add methods to student that were in person? Yeah, obviously, the student can study. The employee can crunch. Okay, so this is problem 3. And so we've kind of talked about it, but yeah, so take a second and go through each of these things of try to access the name field directly, convince yourself. I've shown you that it doesn't work, but convince yourself that it doesn't work. And go through these and check off and see what works, see what doesn't. Maybe work with a neighbor where one person types and everyone else talks about it. Go for it.
That you want to, write something and less visibility, so maybe like you could make something that was public, private.
Right, so public is more visible, private is less visible, or like package visible is less visible.
But you can make something private, public.
Try it out. Try it out.
Nick, could you go back to,
The people know. Okay. Let me open the packet. Okay. Keep working on stuff.
okay, so, is there ever any problem before we were, converting a person into students or,
Converting a person into student. No, we haven't done that
or
yet.
not really converting, but
I think we'll talk about that. We'll talk about that. Because a student is a person, so at some point, we need to refer to it. There's a way for us to refer to it as a person. Okay, what's our progress on this so far? Can we access the name field directly? No, I see head shaking. Okay, so that's no. Can we redefine the get name method to return something else? So over employee, redefine, so overwrite, so public get name. That's gotta have a, wait. I don't know, this one's tricky. So I would like to do something like this dot name, just like still return the name. The way, ooh, this is actually a really good example. We're gonna talk in a little bit about something called partial overriding. Nope, go away. Partial overriding. Which is, so super is the thing for person, right? The super class is person. And so we can, person's got a name, a get name method, and we can call that. So we can say like, super, give me your get name method, and I'm gonna add what I want for my employee. Let's test that out really quick. It's gonna give me something silly. So employee, that's what we said in toString, and then I am an employee, Jeff. And then makes $1 billion, and that's what also came from toString. So this is what we call partial overwriting. So this is technically possible. What about a get age? Can we still use get age without overriding it? See, questionable shake of the head. Thumbs up, thumbs down, or middle if you don't know. Can we use get age without overriding it? There are 2 votes. Let's try this again. In employee, can we access get age without specifying get age in our own class? Yeah. It's like get name, yeah.
Oh, no, nothing.
Oh.
Yeah.
The answer here is yes. It's like we're able to use get name. So, yeah. We can still use it. Can we get away with not specifying an employee constructor? Thumbs up, thumbs down, middling. If we didn't specify an employee constructor, are we all good? That is, let's say I commented this out. Are we all good? No. Gives me an error. It tells me you got to have a constructor.
What problem are we on? Sheet.
We're on problem 3. So that one is no. Wait, if I do a frowny face, does it on? Oh, it does that too. Okay, so can we add new methods to employee? Yeah, we did that already. Can we override get address and make it private instead of public? Let's try it out. Get address is address is a string. And return, I'll just call the super classes version, super.get address. But the key difference here is we want to make it private instead. And we said cannot reduce the visibility of the inherited method from person. So because we said private, that's why this is a no-go. Okay. Let's try. Okay, I'm gonna delete this. This was just here for testing. Can I make name public instead? Maybe, I guess so. We can increase, let's run the people demo. So I'm redeclaring name here and I'm making it public instead. I think it works. So we can increase visibility if we want, but we cannot decrease visibility. And I just remembered, let's take a tangent here and open up our plant UML and see, oh, we're in employee over here. Employee and person. And we've got some interesting things going on here. So if I select these 3 classes in my sidebar, now I can see this relationship where I can see where, you know how we drew that before? This is why. Because we've got the notion of here's a UML diagram. It tells me things about my class. And this translates as well with this extends keyword where we say an employee is a person, a student is a person. And so we can have this diagram show us all that information. And it also tells us, here's the thing that we have in name. And then down here in employee right now, for at least, I've said, okay, making name public for my employee. Yeah. So this is kind of why this is also something that you'll see in Lab 5 and have more experience with that. So these classes now are related. Any questions?
I tried opening up my UML and it's saying like, I have an error with C of some sort.
Okay, let's talk about that after class. It's not critical at the moment. This is mostly just for demonstration. Okay. So we can't reduce visibility, we can increase visibility. Okay, so I've got another task for you. So in your people driver class, I would like you to write a method. So above the main that checks if, or no, actually, sorry. We got to talk about something before we do that. That's the next step. So the next step is to check if an employee and a student live at the same place. I feel like that's a reasonable ask, right? We've got maybe like the parent works for some company and the student lives there, and so they would live the same place. The question is, how do we find that out? Okay, so the way we find that out is that a student is still a person, right? So let's say we want to, maybe we'll have two people and one of them is older than the other. Let's make that happen. Over here. Let's make Jeff 100 years old, and let's make student Bob dot set age 20 years old. Okay, so they've got different ages now. And I want to write a method that says, I'm giving you Jeff and I'm giving you student Bob, who's older? And so this sort of method is what we're going to do. And what we're doing is we've got two types here. We've got student and employee. So if I went to go write my method and I said public static is older, and I said student S and employee E, is this what I want to be doing? The answer is no. Why? Because if I go later on and I say is older, maybe, so if I say student Bob, I also forgot let's name the first one A and the second one B. Is returns returns true if A is older than B. That's the goal. So if I type is older student Bob and Jeff, that'll be fine. I've got an error here right now because I haven't returned anything. So we'll get to that. So, but that's fine. The problem is, what if I want to swap them? What if I want to, maybe I want to see if Jeff is older than student Bob. Let's type Jeff, student Bob. Now this gives me an error saying that the method is older, student employee in the type people demo is not applicable for the arguments employee student. So I've swapped the order. What does that mean I need to do? Do I need to make another method and overload it to say is older for employee and a student? And then what if I'm trying to compare if Bob is older than student Bob? Do I need to say is older person student? Do I need to have all these combinations? No, because that's dumb and really annoying. So we don't want to do it like that. We don't want to hard code to say one of them has to be this type, the other has to be the other type, because that would just make so many of them. Or what's the combination for 3? Is it like, I want to say 6.
I'm turning it one of the.
I haven't decided what it is yet. However many combinations that is. I don't want to do that. I don't want to type all that. So I'm going to refer to it by the super type, where instead of looking at the nitty-gritty of person, student, employee, and all these combinations of 2 of them, I'm going to refer to each one of them as a person. The reason for that is because all of the person, student, employees have age. And so I'm going to just treat them as persons and then get the age and compare it. And that saves me from writing all of these different combinations. So I'm going to say person A and person B. And then this is as simple as what I have here. Just returning if person A is older. So return A dot get age. If that's greater than B dot get age, then it's true. If if B is in fact older, then it'll return false. And that saves me from having to write all those different combinations. So if I run this, it should work. It probably won't print anything. Now it will print something. Not that it matters, just to show you that it works. So it says true because Jeff is older than student Bob. Okay. So we've got about 9 minutes left. So I would like you to I'll switch back to this, but I want to look at the instructions. But before I do that, I just want to say doing this, we're going to talk about genericity later, like making code more generic. This is part of that, where instead of specifying all the different options, we just go up a level, make it more generic, and that's good. And it's also future proof. So later, if we make a teacher type, then this is covered by that. So we don't have to add another combination later. Okay, so take a few minutes and write another method in that driver class that checks if, I said if an employee and a student lives together, maybe make it just if 2 people live together. And I think the active learning for today will be people demo or people driver, whatever I've called it. Okay, let me go back here. All right, go for it.
Can I also submit my subclasses too?
If you want.
Okay.
You don't have to. All I'm looking for is people demo.
I have a person demo, is that close enough?
Yeah, it does the same thing. The name doesn't matter. Oh, yeah. The instructions aren't, it should report true, false if the address is true. What does that mean? I don't know. You know what I mean. If the address is the same, it should be true. Otherwise, it should be false. Bonus points if you use the conditional operator thing we talked about way back when. Remember like the colon and question mark? Try that. Okay, we'll look around. So, I would encourage you to make it also generic. So I know there's like employee and students. So, person know how to get their address. And it's a lot.
I forget how, if I do this, I'm not sure if I'm actually right.
That's probably the simplest way. Yes. Yeah, and then do you check it and make sure?
Yes. How do you, like, how would I change to employee address?
Um. So the employee address, that you would use the. In the driver. Like, see how we set set the age for Jeff and the students on? We don't do like set address. So that's what we call instance variable data. So like Jeff has an address and we want to change to Jeff's address. Not like every person's address as a whole.
Yeah, I'm just writing it and stuff.
Hooray. So we've got two people, those people know how to get to their own age. Really? Okay, so let's see. What other things do I have to tell you about? Trying to decide that. I think so. I will say active learning is give me your people or what do I call it, people driver.java or whatever you've named it. If you name it something different, just give me the demo file. And then that's it for today. We'll come back here next time and keep on going. Thanks for being here. See you next time.